Hey guys, welcome. Thanks for coming and checking out this video on the first derivative test and finding critical points. You guys had some questions and were able to use GeoGebra to find the x's that satisfy these trig equations, but have some questions on actually using the unit circle to do it. So here's another example. Here's our function we're given. We are going to find the critical points, that is, find where the derivative is 0. We're actually on 0 to 2 pi. These functions are their domain is the entire real number line, so we won't have any places where it's not differentiable, just where it's equal to 0. And the derivative of the sine of x is cosine x, and this is going to be plus square root of 3 sine of x. There's the derivative. We want to set it equal to 0, so we want to find what x will satisfy 0 is equal to the cosine x plus square root of 3 sine of x. And this one's a little kind of funny here. Solve these equations any way you can. Watch this guy here. I think you'll agree that the sine of x then is equal to the opposite of the cosine of x divided by the square root of 3. Right? And then if I divide both sides by the cosine, I get that the tan of x, well, I won't skip a step here. The sine of x divided by the cosine of x is equal to minus 1 over the square root of 3, and that is the tan of x. So if we can use our unit circle to find where is the tan of x equal to minus 1 over the square root of 3? Remember, the tan is y over x, so let's look at our unit circle. Minus 1 over the square root of 3. Right here. Y over x, we will have 1/2 over minus square root of 3 over 2. The 2's will cancel, and 5 pi over 6 will be 1, and the other place is right here. At 11 pi over 6, the tangent will be minus 1 over the square root of 3. So we have our critical points. 5 pi over 6 and 11 pi over 6. And we are going to then, the first derivative says, find the critical points, find where the function's derivative is undefined over 0, and then check the derivative value at those intervals. So this is, we are on 0 to 2 pi, so let's check something on 0, something easy in the interval 0 to 5 pi over 6, something on the interval 5 pi over 6 to 11 pi. Over 6, and lastly, something from 11 pi over 6 to 2 pi. Zero to 5 pi over 6, that's going to be pretty easy for us. Let's pick pi over 2. 5 pi to 11 pi over 6. Ooh, easiest thing there is going to be pi. And now here, this is a little tricky, but what we can deal with here is we know that we do know based on what we've found here, right here when we found the critical points, that this is not going to make the derivative 0, and so I can pick 2 pi. Notice that I'm only doing this because I know for sure that there is not an area where it's not differentiable, and I know that we don't have a change in my derivative sign there. So be careful doing that kind of thing. The function now, and remember the derivative is the cosine of x plus square root of 3 sine of x. And we just want to know, is that greater than 0 or equal to 0? So pi over 2. Cosine of pi over 2 and the sine of pi over 2. I might have misspoke there. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. And so we have 0 plus the square root of 3, which is certainly positive, right? At pi, we have cosine of pi plus the square root of 3 times the sine of pi. Cosine here is negative, right? This is -1. Sine is 0. So right here we have that the derivative is less than 0. And lastly, at 2 pi, cosine of 2 pi is 1 plus square roots of 3 times the sine of 2 pi, which is 0. So we are positive on that interval. So we have at 5 pi over 6 to the left, we are increasing, to the right we are decreasing, so we must have a max at 5 pi over 6, and we must have a minimum at 11 pi over 6 since we are decreasing to the left of it and increasing to the right. That's that. Let's throw the function on GeoGebra and see that we have done things correctly. F of x equal to the sine of x minus square roots of 3 times the cosine of x. There we go. I'll put my lines at my critical points. And we were right. We do have a max right here at 5 pi over 6 and a minimum right here at 11 pi over 6. That is that. I encouraged you in the last one to start using your technology to do some of these things for us. For instance, product rules and doing some of the factoring and algebra that might be required to find critical points. So I'm going to do one of those real quick for you. So here's the function, f of x equal to x squared minus 32x plus 4. I'm going to use GeoGebra to do everything for me. Okay. I'm going to turn off my graph so that I'm not tempted to cheat using it. And I'm going to look at my computer algebra system. And we're going to do it like this. So here's our function. F of x is defined as, I'm going to use a colon and an equal sign. This is a definition. X raised to the 4th minus 32x plus 4 equal to 0. And I'm going to do f prime. Oh, so watch this. Solve this equation. I want to solve, since I have f of x already in there, I can say solve f prime of x equal to 0. There it is, x equals 2. And so that's the only one they're giving us. And so we have an interval before 2 and an interval after 2. So let's just find it. Let's do f prime of before 2, f prime of 0, negative, and f prime of 3, positive. So I can look at this right now and say that to the left of 2 Right, to the left of 2, it's decreasing. To the right of 2, it is increasing. So we must have a max there. And further, I will do f of 2. And then I can say that this function has a minimum of minus 44 at x equal 2. Hey, let's look at the graph and see if we're right, huh? A minimum of minus 44 when x is equal to 2. Let's throw the graph on there. Okay, check that out. We were correct, right? And you can see that that is the only extrema on this thing. It's kind of a funny shaped guy. All right, okay. So that's that. Use technology to make things easy for you. Okay? Love you. Keep up the good work. Talk to you later.